Bandwidth for changelog is provided by Fastly. Learn more at fastly.com.
I'm Chris Lamb, and you're listening to The Changelog.
Welcome back, everyone. This is The Changelog, and I'm your host, Adam Stacoviak. This is episode 237, and today we're talking to Chris Lamb about reproducible builds and the importance of having a verifiable path from source code to compiled binary. We talked about all the details of the project, what it means to have reproducible builds, the challenges faced when implementing these best practices, and the inherent security you gain from using them. We've got 3 sponsors today: GoCD, Linode, and our friends at Flatiron School. Our first sponsor of the show today is our friends at GoCD. Head to gocd.io/changelog to learn more about this awesome open source continuous delivery server. GoCD lets you model complex workflows, promote trusted artifacts, see how your workflow really works, deploy any version anytime, run and grok your tests, compare builds, take advantage of plugins, and more. Once again, head to gocd.io/changelog to learn more. And now on to the show. All right, we're back. We got Chris Lamb joining us today. Jared, this show is one of those shows you have to listen to if you care about software security, making sure what your source code is matches the thing you actually embedded into your device or whatever you ship, that binary you put out there. This came from a ping repo issue, though, actually presented by Chris. What do you think?
Yeah, it's reproducible builds is the topic of the day, and this show was very much Chris's idea. So you and I can't take any credit or any blame if there is any to assign. We'll see how it goes. But Chris pitched this to us, and interesting topic, and one, Chris, that you think more people should know about. So first of all, thanks so much for joining us on the Changelog.
No problem at all. Very nice of you to have me on here.
So in the spirit of getting to know our guests a little bit before we hop into reproducible builds and why you believe they're so important, we'd like to get people's origin stories and kind of find out where they're coming from. So can you tell us how you got into software and how you got to where you are today?
Well, my software journey starts pretty early. I guess I was brought up in the UK and in primary school, so I may have been around 7 or 8. I started experimenting with programming on the school computers. But it wasn't until a friend of my mum's was clearing out their a technical guy. He was clearing out his sort of hacker shed of old equipment, and he was going to take it down to the local, where you could sort of get rid of old computers and stuff like that. But on the way, he unfortunately had a small car accident, and the computer that was on the passenger seat went right the way through the windscreen into the field. Police came, etc., and they brought all of the equipment back to his house. They just put it all back in his car. Whatever. He wasn't going to continue on to the tip, as we call it, for some reason. Anyway, he went back, and this computer that was meant to be broken and old, he was this kind of person that, you know what, it'll be absolutely magical if this computer now works. So he plugged it in and flipped the on switch, and lo and behold, for some reason, this car crash had actually resurrected this computer from the dead. And he took this as a sign, so he couldn't throw it out then. And but eventually it was basically in the way of being a doorstop. So he managed to offload it via my mum onto me. And it was this extremely old 8088 IBM computer. It was dreadfully old, even for the time I got it. But it was it had no games or anything on it. It just had a copy of Turbo Pascal, and every 10th reboot, for some reason, it would revert to the basic programming language. There was a ROM built into the motherboard that, for some reason, if the main operating system didn't boot, it would revert to a basic environment. So I got some books out of the library and started programming my own basic things like that. And then eventually on from there, really, just sort of steady state up. Mm-hmm. Moved into some Perl programming, I guess. And by university, I was programming Python a lot, C, C++, and doing, the usual Java, blah, as university courses go and things like that. After university, I joined a startup in London and did that for 2 years. We were acquired. And then because we seemed to work together quite well as a team, we decided to stick together and we did Y Combinator. And I was with that company for 4 years.
Which one was that?
This is a company called Thread.com.
Thread. Okay.
It's still a going concern. Really great guys. I just thought I'd sort of had enough of London by then and wanted a new challenge, and this sort of freelance digital nomad lifestyle was sort of calling out to me. So I sort of jumped 2 feet into that. And that's what I've been doing for the last couple of years, doing freelance projects, doing a lot of Debian work, as in the operating system Debian, and all sorts of really interesting, varied projects sort of all around the world, really.
Wow.
It's been really fun.
Digital nomad. That's a lot of fun. So you're...
Well, it's a pretty pretentious title, but yeah.
Of course. I mean, it's the dream, right?
You're living the dream.
To travel the world and write code and or seek out your personal, hobbies and fun stuff like that in all places. That's a lot of fun.
Yeah, it is really rewarding. I can recommend trying it at least one time in your life.
In fact, you're calling in today from New Zealand, so quite a ways.
That's right, calling from Auckland in New Zealand. I'm looking over a beautiful bay right now, and it's a little chilly here, but it'll warm up.
Going back to that origin story of yours,
yeah,
I can't help but notice that you mentioned that every 10th boot went back to basic. I was just thinking, Jared, how much fun that might be to be like having a computer roulette, so to speak. Like, what will I program today because of the computer and what it will force me to do?
Yeah,
that's interesting. I mean, to some degree, I wonder if all computers did that. Like it, you boot your Mac today and it's not a Mac, it's Windows, or something. I don't know.
That'd be great. Or it goes the other way, where instead of reverting to basic, it says, no, sorry today, chaps, you can only program in Haskell. No.
So origin story, that's a fun piece there. What got you into open source? Where did that happen for you?
Somewhere along the line, I came across a book about Slackware Linux, and it came with a CD and things like that. And this is before the internet was, of any reasonable speed. And so you pretty much have to send off for Linux distributions. And all my computers were always very old, so I was never really playing and being distracted by gaming and things like that. So I played around with the Slackware thing, but even that was very old. So I said there was a company in the UK called the Linux Emporium, and if you sent them, sort of $5 worth, they'd send you, the latest Red Hat CDs on 7 discs or something ridiculous. And I'd heard of Red Hat. Reputable, blah, blah, blah. I get that. So I sent off for that. And they also said, we could include some free extra CDs if you want. So, yeah, sure, whatever. I'm 13, I have no money, so whatever. Send me as much free stuff as you like. Anyway, I went to install this Red Hat, and it said, I'm sorry, sir, you need a very powerful computer. You need at least 12 megabytes of RAM to install Red Hat. And I think I only had 8 on this rather lackluster machine. So I got a bit rather annoyed, and so reached for one of these free CDs, which again were old for the time. They were free because they were the previous releases. And one of them was a very old release of Debian. And the whole operating system there just completely clicked with me. Installing stuff was pretty simple, installing the operating system itself. And I ended up using that for many years just as a user, running my own little web server in between me and my cupboard. Just like, this is amazing. Well, I didn't have the internet, so, I can type in HTTP 192.168.0.2.
But what would be on your web server that you could possibly want to, would you write up there and then read it later? Or what kind of stuff would you even access to your own house?
I don't really know that I wrote then, because that was in my own house. You're quite right. But it was, I think it was copies of software I'd seen on the internet at school. I was Perl-based guest books. They were all the rage at the time. That might be way of aging where it was. Also, it was the beginning time of those short URL redirectors. So this is when you had domain names like i.am. So you would basically a free redirection service like i.am, your name. and it would redirect you. So I was writing sort of Perl versions of those in CGI script.
The good old days.
Yeah, good old days.
I've noticed you're quite a prolific open sourcer in terms of what prolific means. You have lots of open source code. You've been working on Django quite a bit. You've been a Debian package maintainer, I believe, or at least involved in the Debian project since 2008. On your GitHub, you have 216 repositories, and 129 of those are source repositories. So you actually began all of these.
Yes.
What's the deal? Did you just code all day and all night, or how did you get so many things going?
Well, a lot of these things are sort of spin-offs from other projects, or perhaps from freelance work as well. So some of the a lot of the Django tools I've done have been like, well, I think this would be, in the code base, this should be modular anyway, and as it's a completely reusable component, let's just remove it out there, and then it can become more generic, abstract. Other people can contribute to it, etc. And it's sort of good to share back because, etc., etc. So that speaks to most of the Django ones. But the other projects, a lot of them are just scratching my own itch. Like I wanted something to. I think I was looking for a new bike, and there's a sort of Craigslist in London called Gumtree, and so I decided to. I knew exactly what size and what sort of make I wanted, so I made a script to poll it every 5 minutes and to send me an email when something that matched my specifications arrived. And so I was ringing up these people within 5 minutes of their advert going live, going, "Oh yeah, is the bike still available?" And he's like, "I've just posted it, mate. I don't know, how did you get it so quickly?" So a lot of these are scratching my own itch. Some of them people use, some of them people don't use. But I find putting the code out there keeps myself honest. It also makes me follow through on projects a little bit better, because there's some sort of vague accountability if you're putting it on GitHub. Not much, because no one's looking over your shoulder.
Right.
That's the basic idea. Yeah.
I wonder if everybody has the same, I don't know how to describe it, but like the fact that you do some freelance work, or you've done freelance work, over your career, and instead of simply writing it into that code base that you're writing it into, you think in a modular way, and you think about the community. I wonder if that's just like a common thought amongst developers, if that's something that like they need to hear something like your story to think like I should do that too. If I'm writing software for somebody, if I could bake that into my, my contract with them, like, hey, if there's an opportunity for me to open source a module or whatever, obviously I'll disclose that to you or whatever, but baking that into the ability to be a freelancer and actually give back to open source. I wonder if that's just common knowledge to do that, or just common things to do.
I think some of it depends on maybe your attitude and your outlook. So from my own personal perspective, I've always felt like I should only like open source the things that I think are great or useful or polished, and that always leads me to like not open source anything,
The
or
imposter
like
syndrome, basically.
Yeah, it's not really imposter syndrome. It's more like value, like
right.
not non-valuable. Like it's not like I don't belong here. It's just like, who would ever want to use this? But
that's imposter syndrome.
I don't know if it is. It doesn't really feel like
it's an edge case of it.
I don't belong here. It's just like, this is, maybe I just code for myself. So just to compare with you, Chris, just the other day I was writing a little script that you had your bike script that would like check for you every 5 minutes. That was very similar, only it's like a cigar bidding website. Anyways, I like cigars. And so I'm just writing this thing, that's just helping me get cigars at good prices. And like, I never even thought once to open source that. Like, it'll probably never leave my hard drive. But you, on the other hand, you're like, oh, I'm going to put this up on GitHub.
Yeah, I think it also immediately solves the where do I put this file as well.
Good point.
I mean, like, do I lose it in my directory, like random directory structure? But if it's on GitHub, then it's kind of a backup, right? If you squint, it's a backup.
Right.
I hear you say, Jared, it's on my hard drive, where like if your hard drive dies today, Chris's GitHub hard drive does not.
Right.
And even if maybe somebody doesn't find it useful or even desire to watch it or fork it or whatever, or contribute, it's still it's like Chris said, there's a backup there. And worst case scenario, somebody else is like, hey, that's a really awesome idea. I love cigars too. And now you've got a new buddy.
Yeah,
sure. And also like it's a generally like, it uses a mechanized library and it logs in, and it does a few things where if you would like to automate some things on the web, you could look at that little script that to me doesn't seem of much value. And you could say, here's how you might do that. And you could tweak it to your own uses, similar to maybe I could take your bike script and apply it to tricycles or something. I don't know why I came up with that example, but so now I'm talking myself into, I should open source some more stuff. Basically, we should all just be, but aren't we like, somehow we're just maybe like heaving crap out there for other people to sift through, like adding more noise to the ecosystem.
I think there's levels to open source, right? There's like infrastructure open source, which is like in quotes important, and useful.
Right.
And then there's other things that are sort of like tinker tools that sort of just embrace the inner kid in us, the playful manner. And there's a side of that playful manner that helps you get into the state of flow and helps you go beyond just like simply learning. And it's like,
right
now you actually, absorb what you're doing. And so it kind of brings out these different attitudes in the developer behind the code and those who interact with it. So I think there's room for that. I don't think it should all just be so serious. Sure.
I think, in fact, shout out to Cody Peterson, who was our designer on changelog.com, you front ender. He has this idea, which is, I'm sure everybody's had this idea, but he brought it to my attention of like GitHub should have tags, arbitrary tags that you can assign to your own repos in order to provide context. Like you could tag something satire if it's a joke, or you could say, this is a one-off, or you could have all these different tags that would basically say like, look, this was me messing around. It's not a serious project, or you could tag it like serious, the problem with tags is they're so arbitrary. Point being is like, if we could classify our repos a little bit better in public, it might help. What do you guys think about that?
I think that'd be really good, because then I think a lot of people wouldn't be making these decisions about that gray area of, well, shall I put it up there? It's probably not going to be useful. They just put it up there by default, not having to think about it, but just shove one of your tags on it saying, yeah, this is a bit of a toy, probably doesn't even work.
Right.
It's broken now, but it certainly has like more value out there than being on your hard drive. Then it'll eventually die and you'll get lost.
Yeah, absolutely. Well, let's get into reproducible builds. So give us the, I want to call it an elevator pitch because it's not a business, but it's a concept. It's a best practice. It's something that, Chris, you think people should know about and do. It's also something you've been giving sessions on. You spoke at LinuxConf in Australia recently, which is kind of why you're in the New Zealand area. So give us real quickly an understanding of what reproducible builds is, and then we'll come back from the break and we'll dive into it.
Sure. So reproducible builds are a set of practices and philosophy, and it's all designed around to ensure that there's a verifiable path from the source code and the binaries that are being run in your machine. So if you get the basic problem is that whilst you can inspect the source code of free software, most Linux distributions, Android, etc., provide pre-compiled binary packages. And so you needed a way of being able to correlate the binary that's being run on your machine with the original source code. And this is particularly important in the modern era because there's incentives to crack build infrastructure. If you want to, you can go after a lot of users by attacking the developers. And if you can get some malware into a developer's machine, you can infect all of their users in one go.
I never really considered that part of it, Jerry, when we were doing the pre-calls, like the attack on the actual developers.
Yeah.
I was thinking just simply source code in the binary that gets put on whatever and runs and how that gets circumvented, not the developer's machine or themselves.
Indeed. And there's a psychological angle to that as well. I mean, you can, I could hack a developer's laptop, for example, without their knowledge, but also I could come around their house with a baseball bat. I mean, it's pretty crude, but please include this backdoor in your software or blackmail and things like that. So all of these things are protect developers from that happening. So it'll be of no value to threaten a developer with such things, because anything they would do would be caught by the rest of the community.
Well, let's push the pause button real quick, and on the other side of the break, we'll talk more about reproducible builds, why they're important, who's working on them, and what Chris thinks everybody should know and take away. So we'll be right back.
We're working closely with our friends at Flatiron School to promote their free online courses. They've got Bootcamp Prep, Intro to Ruby, Intro to JavaScript, and also Intro to Swift and iOS. In this segment, I'm talking with Kaylee Gray, an alumni of Flatiron School, who started with their free Intro to Ruby course. Then she enrolled in their online web developer program, and now she's working full-time at FBS Data Systems as a developer in Fargo, North Dakota. Take a listen to Kaylee's story.
I studied math primarily in undergrad, but I was also a computer science minor. So I've had exposure to programming, but before Flatiron, I was pretty timid as far as programming goes. I definitely didn't have much confidence in that arena. After Flatiron's Intro to Ruby course, I felt more confident in my ability to pursue programming as a full-time career. One of the things that I liked about Flatiron's Intro to Ruby course was that I was forced to use the terminal, which up to this point had been daunting to me. So it was really empowering to feel like I could go in and make these changes and program these things that I didn't really know I could do. If you're like me and you're curious about programming, but you're feeling a little unsure that it's something that you can do, you can try Flatiron for free and see if it's right for you. And you'll probably like it because it's great.
All right, there's nothing I love more than a success story, and Kaylee is an awesome example. You can follow in her footsteps. Head to flatiron500.com to learn more and enroll. These courses are totally free to enroll. The bootcamp prep course is only available to 500 students. So if you're considering this, do it today. Once again, head to flatiron500.com to learn more and enroll, and tell them the changelog sent you.
All right, we are back with Chris Lamb talking about reproducible builds. And Chris, we gave it a definition before the break. Like we said in the intro, you opened up this idea of saying more people need to understand this as something that's important for various reasons. Can you reiterate a little bit exactly what reproducible builds is, and then again why they're so important, and we'll kind of dive in from there.
Sure, no problem. So this isn't about reliable builds or repeatable builds or anything along those kind of lines. It's really about ensuring that there is this connection between a user or developer can confirm that the binaries that they're running on their system correspond to the source code they're expecting to be run on their computer. So if you kind of wind history back to the sort of Richard Stallman's early ideas about being able to run software on your own computer, whilst you can get the source code for, or a free software operating system and etc., most of these distributions are providing binary packages to you that are being compiled by someone else or different build farms. And it's really important that no inadvertent, malevolent, or accidental changes have been introduced during that code path. There was an example given a few years ago of an open SSH binary that differed just by one bit of 1 byte, which changed a greater than or less than comparison to just a greater than. And just that 1 bit meant that you could have a root exploit. So the difference is, if you ran them through a diff tool, you'd only see that 1 byte change, that 1 bit change. Yet the one would be secure and one would be, well, hopefully secure. One would be hopelessly insecure with that root, with the backdoor in, and one would be hopefully a little bit more secure. So reproducible builds prevent these changes being added behind your back as a user.
So at what level does the reproducible build take place? Is it like, you got your list of who's involved, and it involves various levels of Linux, Bitcoin, things like that? Is it us trusting them to say they adhere to reproducible builds, and that's what gives us faith and trust? Or is it a different level?
I think it's on a different level. It's sort of a kind of community set of tool practices and things like that. If you jump into the details, perhaps reproducible builds is can be quite a misleading term. Code provenance might be a better way of phrasing it and things like that. The way we use the reproducibility is that we ensure that compilation of any piece of software always has identical results. So that means if you run GCC on a C file, you get an ELF binary at the end of it. And if you reran that compilation process, you'd get the exact same ELF binary. The MD5, the SHA-1 checksum would be just identical. Then what happens is that you ask multiple other parties to do their own builds of this same source code. And then you get together, hopefully electronically, and compare your results. So if I got results, 1, 2, 3, 4, assuming that's the checksum, and you got 1, 2, 3, 4, and everyone else got 1, 2, 3, 4, we can pretty much agree that if you compile this source code, you should expect this binary. And if someone came along saying, "Oh, I get 1, 2, 3, 5," you would have an inkling that something was different about his build environment. He could have been hacked. He could have something breaking his compiler and things like that. But basically, there's just something fishy going on that warrants further investigation. So that's where the reproducibility comes from. So the ensuring that everyone gets the same result is where the word reproduce comes in. So if someone can reproduce your build,
sure,
that's where the that verb gets added there.
Hasn't it been for a very long time that when package managers or anybody who's pre-compiling binaries and releasing them publishes their checksums alongside the downloads so that you can download the file and then run your checksum and make sure it matches theirs? Is that basically what you're talking about? Or this is just another level of saying, okay, well, that was 2 computers. We're going to do it on, thousands and make sure that it's always the same.
It's yes, pretty much. I mean, I think when a developer has a checksum next to a file, what they're trying to do, if it's just a SHA-1 checksum, for example, that's typically only to ensure that an end user can validate whether the download completed successfully. So for a very large ISO image, it's very useful to say, oh yes, it did download correctly. So I think that's a different intention there. But you're right. I mean, if you had 100 different checksums that people have provided, it is pretty much like that. So I built this piece of software and I got this checksum, and then if multiple people did the same thing. It doesn't provide any authenticity. So you would need to pair that checksum with, say, for example, a GPG or PGP signature, to sign that binary, to say that I, Chris Lamb, generated this binary, if you see what I mean. So you need to be very wary about what this checksums are actually claiming about the source code.
Yeah, and just to explain it, and you can help me if I don't have it correct, but I think I'll lay out in terms of the checksumming. A checksum is a one-way hash that's run on the binary.
That's right, yeah.
It'll always produce the exact same fingerprint on the other side. The problem with that, especially as cryptographic algorithms get torn down over time, is that while that exact same binary will always reproduce the exact same checksum, depending on your algorithm, there are other binaries that can also produce that exact same checksum. And so that we call them hash collisions. And so that's why it's not giving you the level of confidence that it's secure. It's simply a tool that you can use, like you said, to say, okay, I did get the file all the way downloaded, it's not corrupted or there's no issues.
That's right.
So while people think that those checksums are like giving us some sort of security confidence, they actually aren't. Is that fair?
That would be fair, yes. You can immediately make them a little more secure by providing multiple checksums. So particularly from different families of cryptographic algorithms. So I mean, the advice for years has been to stop using MD5 and things like that. And if you provide multiple SHA-1, SHA-256 checksums, you can start to be pretty confident that your download completed successfully and things like that.
Mm-hmm. So give us the doomsday scenario where, we all go away from this conversation thinking, well, Chris has an interesting point about this reproducible builds thing, but I'm not convinced. I don't care. And so us as a community don't care. We know that's not the case because we have like the Core Infrastructure Initiative is supporting this and lots of distributions and a lot of people do care. But let's say that we just don't get it done and we don't have reproducible builds. What's the worst thing that could possibly happen in terms of hacks or security problems or, use your imagination if we can't have this guarantee?
Well, one advantage is I don't have to use my imagination. Some of them have already happened, although in small isolation. So, for example, someone used social engineering to offer a backdoored iOS software developer kit for download. Maybe they bought a Google ad, that looked like the download link, that kind of thing. So a whole bunch of developers downloaded this, and it worked completely like the normal iOS SDK, except it would replace their adverts, as in any adverts on the developer added, with the attacker's adverts. The idea was to just to make money, really. And so these developers in their making their iOS apps were happily making them. Brilliant, fine. And then they went to upload them to the Apple store, and they signed them. And so the signing process was completely accepted. Apple said, yes, this is you. The signing stuff checks out absolutely fine. But because their software development kit was backdoored, at the very last moment, it would just simply replace the adverts with the ones from the attacker. And they only really noticed when they weren't really getting any ad revenue back. But you can quickly imagine what would happen if the code wasn't necessarily to just replace adverts, which sort of sounded a little bit harmful, harmless, should I say, ignoring the economic blah of it. But what if it was sending your address book or things like that? The original developer would swear blind they're doing nothing wrong. And from their point of view, they are innocent, apart from perhaps some rather lackadaisical security on their part. But you wouldn't really know who to point the finger at. And so that's pretty much the sort of worst case, where you have no idea who these attackers are. You have no idea where the software is going. It sort of seems to bypass a lot of security features that we put in place, like the signing, which is entirely designed to prevent arbitrary code being uploaded to these repositories and things like that. So yeah, that's pretty much the doomsday scenario. Another thing that makes reproducible builds quite salient in modern times is that some of the Snowden revelations referred to using backdoored compilers in a similar way in order to infect machines and things like that. This is something that the NSA we know for certain they've been looking at it because of the some documents released via Edward Snowden. So yes, I mean the doomsday is sort of here already in a sense, but we just don't really know how pervasive it is.
Yeah.
And things like that. Yeah.
It is particularly insidious that you're not, coercing. You don't have a bad actor. The developer doesn't have to be the bad actor if you can infect the developer tools or the developer, pipeline in any way. And then when the point that the attack is successful, like you said, it's very difficult to trace back to the original threat vector when the developer is ignorant of anything going wrong.
Yeah.
And they're usually the one to blame.
That's an interesting story, though, that you can do that with the iOS SDK and do something like you had said, so harmless, but it could have been something so harmful, like an address book or bigger exploits or whatever, that actually takes place. But we all day to day utilize some sort of software, whether it's open source or not, in a way where we just sort of like inherently trust it. I don't know how often either of you do MD5 hashes or any of this thing that you could do to sort of like determine if it's truly what you should be using. How often do you do this, Jared? Like, is this something you do day to day, or how often do you check the software you're actually running?
So I used to use the checksums when I would, like Chris said, when I would download a large file. I used to do it thinking it was a security thing. So a lot of people believe that, and then so it's a little bit of a misunderstanding, is to think, oh, I'm more secure because I do this step.
Right.
And by the way, the other problem with that step of I'm going to download a file from this web page and then I'm going to run the checksum to make sure it's the same, is that if a hacker actually hacked the web server, insofar as they could replace the binary that you're downloading,
Right.
they also could have very easily changed the checksum to match that binary of the
Right.
So it's completely not a security thing, even though I used to think it was for a long time. And so that's more when I used to do it. But also back in the days where, a 600 meg Debian ISO was like an all-day download, you wanted to make sure that it worked right. And so I would do it back then. But I don't do anything. I'm very security lax, sadly, in my current.
Well, how much binary code are you running these days that where you would check it? Like, how often are you, either of you, using anything that's binary where this plays into, where you take a source code down to one file or something like that?
Well, I mean, anything that nowadays, Homebrew has a lot of precompiled binaries.
Right.
And I assume Homebrew has some built-in, I know there's some certificate checks and stuff going on there. Chris, you can probably talk to Debian's process since you're involved in the Debian package maintenance. But what kind of security is in place around package managers where people are precompiling binaries and then, we're downloading them and using them?
The Debian and by extension Ubuntu and Ubuntu Mint, etc., they use internally they use GPG and signing.
Mm-hmm.
So there's a known web of trust. So whilst it does validate the checksums of the files when it downloads them, that's simply for integrity. In other words, has the download completed successfully. But there's an additional step which is documented. I think if you search for apt secure, there's a quite interesting wiki page on the Debian wiki about it. In a nutshell, it basically uses GPG signatures and a keyring of trusted keys to say, okay, the checksum of this file is X, and we have a valid signature that's in the keyring, so therefore we can trust this file to that degree. You see what I mean?
Yeah.
Whilst you're completely right, that prevents your example of the attacker being able to get into one of the many Debian errors and replacing both the checksum and the binary. That would fail because they would not be able to forge the signature, the extra step.
Right. So there's that, and then if we go into like the Apple side of things with the iOS, App Store and whatnot, those are all developer signed. You have to have your own certificate and sign your binaries before Apple will accept those in, and there's a web of trust that they create in there as well. So there are things that are in place, but what you're advocating for with reproducible builds is even more guarantees, not just that these binaries are trusted, but that we can verify their origin, the source code that originated them, in a reproducible way.
That's right. That's a good summary, because whilst you could have using the checksum and a signature, I know that I got this binary from, say, you, and it's like, brilliant, I know exactly who I've got it from. There's no guarantee that corresponds to any particular source code that you claim it belongs to. I have to take your word for it.
You have to actually trust me.
Yes, for that sense, yeah. With the reproducible build setup, you could provide the source code in that binary, and I could not only compile it myself to say, yeah, okay, it does check out. I can also ask multiple third parties to perform that same step, and then I can start to trust you and be saying, yes, this checksum with this signature does correspond to this particular source code.
Yeah.
So it's sort of extending that one level back.
Right. So you gave it to us before, but now that I feel like we've kind of wrapped our heads around it a little bit more. Explain it to us again in terms of the process. So reproducible builds is not like a feature that you checkbox. It's a set of practices that you can operate under as a development community, right? That gives you this verifiable path back to the original source code. Describe it to us again, the steps that get put in place before we can say, you know what, this is verifiably reproducible. Sure.
So the steps are, the first step is you ensure that your source code always produces the same result in a bit-for-bit identical way. So this is removing any timestamps, any variations based on your time zone that you're in, any non-deterministic behavior, any randomness and things like that. Basically, so if anyone took the same source code and recompiled it themselves, they would get the exact same binary out that was completely bit-for-bit identical. Then you ask multiple parties or multiple, build servers or distributed around the web at different isolated environments, perhaps, to compile that same source code. And if they get the same result, if everyone gets the same result and that same binary that you got, then you can start to say that, oh yes, this binary here corresponds with the original source code. And therefore you can make this claim that as it's very unlikely an attacker would infect everyone simultaneously, that this really is the binary you get when you compile this source code. There isn't any nefarious goings on, and nothing has been introduced along the development tool chain. You see what I mean?
So who all is involved in this process? We mentioned it before, but you've been awarded a grant from the Core Infrastructure Initiative to work on reproducible builds. Is this something that the Free Software Foundation is working on? Is it the Linux Foundation? Is it Debian? Give us the lay of the land on like what actors think this is important and are actually putting efforts towards putting these systems in place for a lot of our underlying operating systems and other things.
Well, it's quite a diverse group of projects, really. I mean, there's you can find some old mailing list posts about people sort of attempting this in the mid 90s, but wasn't really on anyone's radar as a security vector for a while. And after the Snowden revelations and the iOS, etc., a lot of people started getting interested in it. Debian was perhaps the forefront of the distributions, and certainly putting a lot of the initial activity into reproducible builds. But now we're a completely distribution and project agnostic initiative and endeavor. It's the Linux Foundation that are very generously funding my time and others' time to work on this. But there's all sorts of distributions involved now. We've got SUSE, Fedora, Geeks, a bunch of BSDs as well. So it's not even a Linux only operating system of Arch Linux. But we also have projects such as Bitcoin and Tor. I mean, you can imagine the incentive to crack the binary of a Bitcoin wallet.
Mm-hmm.
If you could upload a backdoored Bitcoin wallet and replace the developer's version, you would become rich fairly quickly. You see what I mean?
Mm-hmm. That's my plan.
That's your plan. That's your retirement fund.
Yeah. I don't even know why you're saying this. I mean, you're telling everybody my plan. It's I'm just going to skim a little bit,
just a little,
off of everybody's Bitcoin wallets and become rich.
Yeah,
just a fraction of a cent every transaction.
Yes, sir.
They'll never notice.
Yep.
But it's pretty scary. I mean, to go back to the psychology earlier. I mean, imagine being that developer. You're sitting at home. How much money could you make by adding a backdoor to that Bitcoin wallet? How much would it cost to hire a bunch of heavies to go around of his house? I think the economics would work out. The moral economics perhaps wouldn't. But just in terms of money, very scary. So if I was that PP person, I wouldn't want to put myself in that situation. I wouldn't want to put myself at risk for being targeted in that way.
And before we go into the break, I want to ask maybe a hypothetical. Maybe I'm just being naive when asking this, but because I don't do this too often. But it sounds like reproducible builds is a philosophy and a set of best practices that enables you to verify this binary from a source. And often we have the option to, pull down a compiled version or a precompiled version of whatever we're using. Why not just opt to compile yourself? And that essentially, if you're compiling from source, you're essentially doing the same thing as reproducible builds. Like you're actually.
That's right.
You know what I mean?
It's still absolutely, but it's a convenience factor.
Right.
People don't do that too often.
No, and
Gentoo users would disagree, right?
They would disagree, but they would disagree on many things. I much love Gentoo users. But I mean, for example, do you really expect your phone to compile the software before installation? I mean, I wouldn't want my phone to have to sit there and compile Chrome before it gets installed, for example. That would be a little bit inconvenient.
I'm thinking more at the developer level.
And drain your battery, Adam.
Yeah, I'm not thinking like at the end user level they're going to do that, because that's just too much to ask any user to do. I'm thinking like at the developer level. Maybe I'm closed-minded and only thinking of this in one lens, but so far the concern here had been like installing a Linux version or iOS SDK. I was just trying to play the devil's advocate of why would you just not compile yourself? I guess if it's a developer tool.
Yeah, I think convenience is a huge aspect of that. I don't know when it was, but coming from the Mac side, Adam, like I said, Homebrew now has precompiled binaries for lots of packages that you install often. And so if you have to compile Postgres from source every single time you have a point update, that could take, depending on your machine, it could take 10 minutes. It could take 40 minutes. Who knows?
Right.
And so if you have every single piece of software that you run, you're going to compile from source. How far does that go? Do I also have to configure it myself and make sure I've actually configured it correctly? I think there's a huge inconvenience there.
Well, it may be missing a bigger picture here in that the security affordances that reproducible builds provide should apply to everyone, really, to all users on any technical spectrum. So they don't want their to-do list app and things like that they're just using as a thingy to have any backdoors in.
Well, I think the bigger picture there is just trying to figure out, I'm just thinking if I'm a developer and I'm going to use something that has a binary, why not just compile it myself? And none of the arguments you've made there of the conveniences and affordances, and if I'm going to every point release a Postgres, I'm going to recompile a new version of it. That's probably a big pain in the butt. I'm just trying to figure out, I guess, is reproducible builds, this philosophy, this best practices, is it enabling me as a developer to have the ability to reproduce it if I wanted to, and that's the security, or is it
Absolutely.
okay?
Yes.
So if I wanted to take the convenience hit to actually compile it myself, I could, to prove that what I've gotten is coming from the source.
Indeed. And what our goal is in the Reproducible Builds project is that there are enough people out there already building the software that you can simply rely on those people to provide you with a checksum that has consensus across, say, 20 or 30 different people. And so you would never really have to rebuild anything yourself, because all of these 30 other people agree that the binary should be X. You also have binary X. I'm happy with that. That's fine for me, and things like that. And that also speaks to the end users as well. So they don't have to compile software themselves necessarily, and if they want to, but if they just want to install a random app on their phone, some sort of to-do list, for example, they can trust that the 30 or 40 rebuilders, as we might call them, agree on a particular checksum. And as they've got that same checksum, they're happy installing that and saying, okay, cool, the binary I've got corresponds with this source code. There isn't any nefarious, nasty stuff being added somewhere in the mix along the line.
You've certainly given me a speckle of fear when it comes to installing potentially nefarious apps in the App Store, because like there are times I want to use an application in a genre, like for example, recently, like with music or something like that. I'm just like, I don't know if I should trust any of these people because I don't know any of the brands. The design isn't that great. So like there's some known trust factors you sort of apply to potentially trustworthy software. And that doesn't exactly define security or trust like by its look, but it certainly helps it if you care enough about its design that it's trustworthy. But just in general, you've given me this slight fear that somebody out there is using a hacked version of iOS that's replacing ads and or stealing my data, and now I have complete fear. But let's break that. Let's not open that can of worms. My fear's out there. The world knows about it. Let's break. When we come back, we'll talk about other advantages beyond security, things like that. So we'll break here. We come back. We'll go into that with Chris. We'll be right back. Linode is our cloud server of choice. Everything we do runs on Linode servers, the most efficient SSD cloud servers on the market. And you can get your own Linode cloud server up and running in seconds with your choice of Linux distro, resources, and node location. They've got 8 data centers all across the world, North America, Europe, Asia Pacific, and plans start at just $10 a month. You get full root access for more control, run VMs, run containers, a private Git server, enjoy native SSD cloud storage, a 40 gigabit network, Intel E5 processors, super fast. Use the code CHANGELAW2017 for a $20 credit, unlimited uses, tell your friends. Once again, CHANGELAW2017, head to linode.com/changelog. And now back to the show. All right, we're back with Chris Lamb talking about this awesome thing called Reproducible Builds. You need it to have secure software, and maybe it's just a pain in the butt to compile from source, as I learned that today. It can't do that every day. But Chris, take us through some other advantages. I mean, obviously you got some security advantages here. Where else should we go for this to help explain to the community why this is so important?
I think the biggest non-security advantage is, given that every time you rebuild the software, you should get the same result. It means that if you make a tiny change to the source code, you should expect there should be a result in the resulting binary. And only those changes should be apparent in there. You want to do a new release of software, and you want to make sure that this new release only contains the changes that you want. Reproducible builds make it very easy to analyze that, your new version with the previous version. And if you compare them, you should only see the changes that you expect. We've even written a very good tool for this called Differscope, which can recursively unpack binaries and things like that and look inside them and provide a human readable view on a particular binary. For example, it will decompile Java files and things like that, and pretty print Python source code and JavaScript source code and things like that, which makes it very easy to say, okay, I've released a bug fix release for this particular thing, and only the changes I expect are in this new release. So that's fine. I'm happy to push it out. Now, this is a massive boon for anyone doing security releases, for example, but it's also just if you just want to have really good quality assurance. You want to ship something to your users, You don't want to have any inadvertent changes like, oh yeah, it pulled in this extra dependency, whoops, and now it's broken everything. Oh yeah, so sorry. If you just change one line of code, you should kind of just see that reflected in the resulting binary. The other advantage when things always build to the same result is that you, just by design, you get better cache hit ratio. When you speak to the guys at Google about this, they're saying this is saving them thousands and thousands and thousands of dollars, simply because when they compile a large piece of software, many parts of it haven't changed. And as they're reproducible, they will always produce the same result. And so therefore, it just says, well, there's nothing new to compile. So therefore, I don't need to do anything. So you can reuse the previous result. So this is not only saves developer time, it's saving the company money, but also it's saving the environment in a sense, because you're not, wasting CPU cycles and generating CO2 and things like that. Further technical advantages are, by design, it removes any unreliable or non-deterministic behavior in the development process. So if you want to get the same result, your build can't rely on anything that's based on timing. So any quote unquote unit tests that do, for example, using time to check whether something should run in a particular speed or in a particular ratio of inputs to output time, algorithmic complexity, as it were, that becomes unreliable and therefore non-deterministic, and therefore can't be part of a not reproducible build and things like that. It's a good way of finding bugs in uncommon time zones and locales. So the 2 or 3 times I've come across it, it's been Ruby libraries. So I'm not sure, but a few Ruby libraries that have been designed to manipulate dates and times. Their test suite fails when you run it in, for example, UTC plus 14, which should be a little worrying, because this is a library that the developer might be using to say, okay, I know time zones are difficult and date processing is difficult, so I'm going to leave it to this library, and the library, it doesn't actually work in these strange locales and things like that.
How would the reproducible builds help you track down the specific time zone based bugs then?
So within the Debian project, we have a reproducible torture chamber test. So what we do is we build every piece of software in Debian, and there's 23,000 different source packages there. Give you a scale of what we're talking about. We build it build it twice, one after the other, the A build and the B build, and we try and vary as many things between those 2 builds as possible. So, for example, the second build will be on a different CPU type. It'll be done a few years in the future. We just set a fake time and things like that. We change the shell. We change the path environment. We change all the environment variables we can possibly change. Your username, anything we can think. We change the file system. Basically, anything you think of, we try and change. And this hopefully surfaces as many differences that would affect reproducibility. So we want to make sure that any end user can compile the software on their own machine, regardless of their own local environment, and get the same result. And so this is a way of reducing the set of variations that would actually result in a variation in the end binary. And this also shows up some of these QA advantages as well.
I mean, wouldn't that would help suss out compile time differences? But what about runtime? Like I'm thinking about like things that are JIT compile, like Ruby, for instance. Like how does it suss out those problems if you're packaging Ruby things?
You're quite right. As they're JIT compiled, what gets distributed then is the Ruby source code. So although it's a little, you have to squint, the binary for a Ruby package is actually still, sort of text-based Ruby code and things like that.
Right.
Saying that it can still surface interesting things, and just on this one happens to be a security piece. If there was a repository browsing tool that had an OpenID-based login system, and during the build process of it, it was generating a OpenID secret. You know how it's based on a secret that the server knows about, and it uses public keying, encryption, Diffie-Hellman, etc. style cryptographic algorithm to validate logins are secure. So during the build, it would generate a random number and that would get put into the binary package. Unfortunately, this meant that every installation of this browsing tool would share the same secret.
Yikes.
Because, yes, this was surfaced in our QA torture environment, because in the A build, it would generate secret 1234, and in the B build, it would generate the secret, 1943 or whatever. And we would flag that up as, oh, it's different between the A and B build. What is different? It's some sort of secret key. Oh dear, this should not be the same for all the packages that get built.
You guys have a reproducible build torture chamber. That sounds terrible. I
like the name.
It definitely conjures thoughts of visualizations. Probably it sounds like it's well named if you're definitely changing so many things. You're putting it through, torturous things. Thinking about how do you this is the Debian project. You guys have a great setup. You put time and money into this. How do other people do it? There's a set of best practices. You've described the process, which seems relatively straightforward. There's a few steps, but tactically, how do you go ahead and say, you know what, our group is interested in reproducible builds. How do we get from where we are to where we want to be?
A lot of the work is being done with liaising with compilers and other tool chain based utilities that are introducing non-reproducibility. So we speak a lot with the GCC developers. For example, we had C developers will know the __ date and __ time macros, C preprocessor macros. And previously they embedded the date and time directly into the source code as macros. This affects reproducibility because obviously every time you rebuilt it, it would put the current time in. And so therefore every single time you would build, you get a different binary. So a lot of the time we are speaking to developers in those kind of areas rather than developers of, shall I call them, leaf packages, sort of ones that depend on other packages rather than where packages are depending on them. Documentation generators are another example of upstreams that we're speaking to quite a bit. In terms of just getting the word out about the potential problems of a world where we can't trust the binaries that are running on our own computers, that's a lot of what we do, and talking about the problems and talking about the doomsday scenarios to be outlined before.
Mm-hmm. So we've outlined a little bit who's involved, and you mentioned all these different projects doing it, working hard on this: Arch Linux, Bitcoin, Debian, FreeBSD, NetBSD, so on and so forth, Tor. Who's not involved that should be? If you could get their ear and say, you guys need to be doing reproducible builds, and here's why. What are some groups or some people or some companies that should be, doing these things? And as far as your knowledge is that they aren't.
Well, one thing we know they aren't in that basically sort of people outside of the free software space. I mean, for example, what made the recent Volkswagen emissions scandal possible is software that has been designed to lie about the sensors in a lab environment. If you had the source code under public scrutiny,
sure,
adding some sort of misfeatures would have made that sort of impossible. I mean, without reproducible builds, it's hard to confirm that the binary code installed in the car was actually made during the source code that had been verified, if you see what I mean.
Well, nobody has access to the source code anyways, right? So,
well, yes, that should be that's a sort of
so anybody who has proprietary source code, they're not going to be doing reproducible builds as far as a public community has access to them, because their source code is private anyways.
Yeah, that's true. But because of things like the emission scandal and things like that, we may see more legal-based,
mandatory
requirements for these things to be.
Yeah.
And then even if someone did provide the source code for a piece of software and along with the binary, in other words, your car, we would still need to be able to verify that one came from the other.
Well, you would think the EPA might step in there, Jared, where general public may not have access to source code, but maybe because of this emission scandal, maybe a new law or something is put into place where the EPA has to have access to the original source code to produce a reproducible build to confirm that the software installed in the car matches the result they got from source. I mean, that's a possibility there, rather than saying,
sure,
open the code up to the world because it is proprietary. Maybe certain security levels might have to be in place, and that just means bigger government. So different podcast altogether. Something I wanted to ask, maybe we're talking about who should be involved, but I was thinking maybe I was almost going to interrupt you, Jared, but maybe now that I have the chair here, I can ask it. Going back to the example originally with the iOS developer who got circumvented and pulled down the wrong version of the iOS SDK, what could that person have done differently to prevent them using a scrutinized iOS SDK?
Well, one, they could have, the obvious things of ensuring that they download it from a reputable source. Assuming that Apple are not going to release the source code for the SDK, which is probably a given, there's very little they can do. And that's basically the quote unquote risk you take when you run proprietary software. What hopefully would have happened is that if they were in a free software world and they released the source code for their software, it would have been very obvious and very quickly that the binaries that they were producing did not match with their source code, and they would never have matched because of the way that their SDK was introducing the change of adverts and things like that.
Mm-hmm.
So hopefully very, very quickly, when a third party recompiled their piece of software, they would say, that's interesting. You're distributing checksum A, B, C, D. But when I compile it myself, I get D, E, F, G. What's going on here? And questions would be raised very early and things like that.
So in the case of this SDK, they pulled down iOS SDK, download it from a reputable source, which seems to be a logical first step. But let's say they didn't. But since it's proprietary code, they can't essentially leverage this best practices of reproducible builds because they don't have access to the source code and they can't confirm that.
Indeed, yeah.
So they're screwed, basically.
Yeah.
They're forced to use this nefarious version because they downloaded it from somebody's hijacked website, not apple.com/developers or something like that.
Mm.
Back to who should be involved, because I had that thought in my head, but I want to go too further, but I do want to get back to who's involved. So we've got a list here. I think the URL is reproducible-builds.org/who, and you can go there and see everybody involved. And Jerry's question was like, specifically, who's not involved in this that should be involved in this?
Well, I wouldn't want to embarrass anyone in particular.
Oh, come on.
Well, maybe it's not an embarrassment. It's just more like a call to arms. Get in the pool.
Yeah, convince them.
Get in the pool.
Don't embarrass them. Convince them.
So someone who's not really represented here is Ubuntu, and they do have use their large installation base. That would obviously be great leverage and would provide a lot of reassurance to a lot of users if Ubuntu got involved. We have actually spoken to them, and they are kind of waiting to see whether the Debian toolchain, etc., kind of settles down because it's a little bit in flux at the moment. So they have no philosophical objection to it. It's just not on their radar right at this second. But hopefully that will change in the next 3 or 4 months, and we'll start to see some of the Debian reproducible builds work trickle down into Ubuntu, like a lot of the other work that's shared between those two projects. So I think that would be the main one that's missing in terms of user leverage. In terms of people who don't really care about it, I guess anyone in proprietary software can't care about it because they, it doesn't really work if you don't.
They're not forced to, at least.
Yeah, indeed. So I can't really speak to them. I mean, it'd be nice if more Windows developers had that kind of mindset and things like that. But there's still a lot of free software that's being developed for Windows. I mean, things like Putty, a whole bunch of browsers are free software and released on Windows operating systems. So perhaps more in that space and things like that.
Microsoft themselves could definitely get involved when it comes to open source developer tools in their ecosystem. They have many, .NET Core and Visual Studio Code and many things that have been open source for a while now that they could at least, and developers are relying on them as their tool chain. So they could get involved. That's
true. They could certainly help ensure it will certainly make it easier for developers to make their builds reproducible. Yes, that would be very nice to see. And that, again, it would be another great source of leverage there. And it'd be one company getting involved and would help quite a lot of developers and users.
What about at the individual level? Jane developer, Jane web developer and Joe game developer, Linux users, people like Adam and I, our listeners out there that maybe, we take security seriously. Maybe we could do better, but what can we do to help this initiative?
So one thing is you can ensure that any source code you do release can be built reproducibly. So this means removing any timestamps from the build, ensuring that it produces the same result in as many different environments as possible. It doesn't have any varying behavior, things along those lines. Most software would not require any of these things, but a lot of software likes, for example, likes to include the version which is based on the current date, or they like to include the machine name that it was compiled upon and things like that. So removing those sort of things is pretty much the first step, and for most software, the only step required to make the build reproducible. The other thing you can do is to occasionally check whether the code that you're running does match the source code, and if it doesn't, raise a red flag to whoever is producing that binary and the source code and saying, that's interesting. You're providing this binary and this source code, they don't seem to match. What gives?
Would they compile their own version? Would they use this torture chamber you're mentioning? Like, what's the step they take to ensure that?
I think right now they would compile it themselves. That would probably be the easiest way of getting a single checksum, rather than setting up a torture chamber, because that requires isolated environments, changing clocks, etc., and things like that. So the first step would just be to recompile it on their own machine and see what they get, and compare it with the result that's being distributed by the original source code maintainer.
I feel like that's still a hurdle that most people will just be like, whatever. Maybe I'm just being agnostic against it, but I feel like we're back to the same original problem where we said, you're just verifying a checksum. Essentially, you're back to, which is what you want, because you want to reproduce a build by compiling, which is the question asked kind of in the middle there, where why don't we just compile the software ourselves? And that's essentially what we're doing to confirm we have the right thing. So if they're not going to do it to use it, I'm just wondering if there's an easier hurdle to put in front of people to get over versus that one.
I suppose one difference here is that checking the checksum not only helps Jane developer, it also helps when they are validating a checksum, they're also checking it for the rest of the community as well. And they're also checking on behalf of the original distributor as well. It's not just helping them. And so if they built all their binaries themselves, it would be, it's too strong a word, but something like it would be sort of somewhat selfish to do that, because only they would reap the advantages of doing that recompilation. But if they recompile and check with the upstream's version of that binary, what they're doing is helping the community at large, saying, I've confirmed that this binary matches this source code at least. Does anyone else want to have a go as well? So it's a little bit more friendly in that sense.
On the note,
it seems like.
Sorry, Jared, go ahead.
Well, I'm just trying to think of like ways that we could actually get people to do something on this, because I agree that like the ad hoc, check a binary here, check one there type of a thing probably doesn't have much legs with people. But it seems like there could be some like community tooling built around some sort of reproducible build chaos monkey thing, somewhere like how Netflix has on their internal networks. Yeah. Where you could just like build a system that like pulls a random GitHub repo. Maybe it has to be language specific or something, but spins up an EC2 instance, runs the build, gets the checksum, checks it against, the published or whatever. And then like as a web page with red, people with red X's and green checkboxes or something where it's automated, but accessible and, community effort. I don't know, Chris, is that?
Indeed. Yeah.
Well, he said recompiler earlier. That's what I was going to ask before I was going to interrupt you, but you went, it was Chris, didn't you mention something about recompilers, a farm or something like that earlier in the call that we didn't go into? That's
right. Yes. I think I referred to them as rebuilders.
Rebuilders. Yes.
That sounds cool.
Yeah, I think it's a pretty cool idea. It's quite interesting philosophically as well, because you would want as many different and diverse groups of people recompiling the software, because if you did have a community effort, whilst you've removed the original building of the binaries, if you have a central community way of doing this, you've essentially then re-centralized the confirmation of all these checksums. So you want as diverse a group as possible building all of the software all of the time.
Yeah.
For example, you might have servers in Greenpeace's data center or the Department of Defense's. People with rather different views of the world, but if they can agree on the checksum, the final checksum of a binary, and they have different motives in this world and things like that, then you can start to say, I can trust this. Yeah, cool.
It'd be kind of like SETI at home, only the results would be actually useful.
It would be very much like Steady at Home. I never thought of it that way. Yeah.
Rebuilder at home. There it is. Somebody go out there and build that thing, and we'll all just dedicate CPU cycles, at nighttime when we're sleeping to
There you go.
making sure all of our software is secure.
That'd be amazing. I'll get onto that.
So that's what I was getting at. It was like this hurdle to do the thing that, does what we're trying to do with this conversation and this entire initiative and this best practice is like that last step, as Jared said, is going to be less likely to be done by the general public if it's just sort of like, if I think Jared's doing it and he thinks I'm doing it, neither of us are doing it, right? And maybe a small handful, and those are the people getting burnt out. Those are the people giving talks. Those are the people running meetups. Those are the people getting pulled every which way forward, and those are the people getting burnt out. And it doesn't scale. It doesn't sustain. We have a Heartbleed issue again, or we have another issue, or we got an emissions scandal going on because this rebuilder process is just too hard to put on the individuals of the world.
Indeed, yeah, and that's probably our weakest point at the moment, is how we can really translate the reproducible builds effort down to the end users.
Yeah.
So, for example, providing end user tools to say, you're about to install this particular binary, but we don't believe it's reproducible. So what do you want to do about it? We don't have tools for doing that yet. We don't have these sort of automated, or at least semi-automated rebuilders yet. It's certainly in the pipeline. It's just that we are still not quite there as a project in terms of, we'd like to move the reproducibility effort on a little bit further before we attack those angles. And there's a few unresolved questions as well. I mean, just for one example, say we had 10 different builders, Greenpeace, Department of Defense, you, me, etc., all publishing their checksums for their binaries. What would be the algorithm the end user tool used? Would it say, all 10 have to agree? Do 9 out of 10 agree? Is that okay? What if I'm a malicious actor and I upload 10,000 checksums that are all bogus? Would they outvote the others? There's these difficult questions that haven't really been resolved yet in terms of policy.
Put it on the blockchain.
Mm-hmm.
Blockchain solves all problems. It's the new spade card or trump card. Just say blockchain, and then that's the answer.
Well, blockchain would be part of this thing to ensure that someone could not unpublish their checksums. So yes, we are actually, ironically, thinking of using blockchain-like technology.
I'm full of good ideas today. I tell you what, that's 2 in a row.
I feel like you should join our project.
Yeah, maybe I will.
Well, Chris, in efforts of closing up here, what closing thoughts do you have to share? This is last chance on the show to sort of get that final person who's like, I really like this idea. What's the next step? What final closing thoughts do you have on this?
I suppose if someone's vaguely interested in the project, they should totally check out our website. It's got a bunch of talks, a bit more background information, some recent presentations with some more interesting gotchas about interesting things that we have surfaced QA-wise in the reproducible builds effort. We also have a mailing list and some interesting, as I mentioned, our Differscope tool. So one thing that everyone can try right now is a website called try.differscope.org, where you can upload 2 files and it will recursively unpack them. So if you give it 2 ISO files, it will unpack the ISO files and look for differences look for meaningful and human readable differences between those 2 files. That software is also available on your desktop, but this is just a web-based interface to it. So that would be the next things to check out if someone's interested in the project.
Good deal. Well, we'll certainly leave links in the show notes to reproducible-builds.org, which is the site that Chris is referring to. The talks, resources, tools, events, even the news stream you have there is great, great documentation. So highly encourage those who are listening to this and interested to check that out. Check the show notes for that. And Chris, thanks so much for joining us on the show today, man. Really appreciate it.
No problem at all. Thank you for having me on.
Thanks again to our guest this week, Chris Lamb. Also, thanks to our sponsors, GoCD, Linode, and Flatiron School, as well as Fastly, our bandwidth partner. Check them out at fastly.com. Our theme music was created by Breakmaster Cylinder, and this episode was edited by Jonathan Youngblood. The best way to keep up with all things open source and software development is to subscribe to our weekly email, Changelog Weekly. Head to changelog.com/weekly to subscribe. Don't miss an issue, and thanks for listening.